Hello, and welcome to my presentation on backward design, the Understanding by Design method and Bloom's taxonomy. In this presentation, I will introduce these three concepts and then provide an example of learning objective development using them. First, I'd like to talk about the Understanding by Design method, otherwise known as UBD. UBD is a framework for designing learning courses created by Grant Wiggins and Jay McTee. It emphasizes a strategic approach called backward design. This approach begins by specifying the ultimate goal. What are the desired final outcomes for the students? And this is going to be the focus of the presentation today. In order to create meaningful, measurable, and achievable goals, the UBD framework suggests categorizing the information that will make up the course into three different categories. First, what info is worth being familiar with? This is the least critical information that may be incidental to the main goal. Next, which info should be mastered? These are facts, concepts, principles, processes, strategies, and methods students should know when they leave the course. Finally, what are the big ideas and important understandings participants should retain? These are referred to as enduring understandings because they are the ideas that the instructors really want students to learn most deeply. As potential course content is considered and categorized into one of the three areas, the instructor can begin to determine the best content and begin to formulate the ultimate course objectives. Once the instructor knows what the desired outcomes of the courses are, the next step in the UBD framework is the plan on how to prove that the goals are being met. The nature and frequency of assessments depends heavily on the content of the course. Process-heavy courses such as mathematics may have need to verify that students have memorized formulae and will be able to apply them in a variety of contexts. An English Lit course may require that students be able to prove their comprehension of a reading via essays or group activities like debate. The UBD framework stresses the importance of aligning all three stages with one another, so the assessment stage must derive its content directly from the objectives formed in stage 1. There are 6 facets of understanding that the authors suggest focusing on for a culminating assessment of a student's understanding. The student should be able to explain concepts in their own words, interpret using images, models, or stories, apply knowledge to new concepts, demonstrate self-knowledge by showing awareness of metacognitive processes and reflecting on the meaning of their learning experience, empathize with others, and demonstrate their own perspective by seeing the big picture and other points of view. One should strive to consider using only those facets that are appropriate for the content of the course and maintain alignment with the course objectives when creating assessments. Once the learning objectives and assessment methods are established, the instructor can now begin planning the content of the course. This will include strategies meant to best provide materials and information to the students. Bowen suggests that instructors ask themselves some questions during this process as prompts. First, what enabling knowledge, that is facts, concepts, and principles, and skills, being processes, procedures, and strategies, will students need in order to perform effectively and achieve the desired results? What activities will equip students with the needed knowledge and skills is the next question. Third, what will need to be taught and coached, and how should it best be taught in light of the performance goals? Lastly, what materials and resources are best suited to accomplish these goals? The hierarchical learning classification model, developed in 1956 by Dr. Benjamin Bloom and colleagues, meant to streamline test formulation by creating a bank of questions categorized by levels of learning assessed, is commonly referred to as Bloom's taxonomy. Dr. Bloom also wanted to address the lack of a coherent, standardized language to describe educational goals. For example, general phrases such as "students must understand a concept" or "students will learn a set of facts" did not convey what the learners were actually expected to do after working through a curriculum, and this problem was the basis for the framework's design. In Bloom's original taxonomy, knowledge was seen as the basis for all other learning processes and was subdivided by the various uses of the knowledge. The hierarchical factor meant that it was believed that a higher cognitive process could not be applied to the subject at hand without the student actually having mastered the previous process. Both the original and revised versions of the taxonomy are commonly represented as a triangle or pyramid. Here we can see the original version with knowledge as the base and the higher learning processes built upon it. Although the original taxonomy eventually became widely used in the design of learning curricula, Dr. David Krathwohl refined its structure in 2001 to facilitate the formulation of learning objectives and for evaluating existing curricula and assessment tools. Specifically, Krathwohl reorganized the original knowledge dimension to more closely represent the terminology of cognitive psychology, which had not yet emerged at the time of the original framework was developed. In doing so, the sentence structure of the dimensions was altered to allow knowledge to encompass the noun aspect of a learning objective, that is, what is being transmitted. Meanwhile, the cognitive learning dimensions were reworded to represent the verb aspect of an objective in the infinitive. For example, remember replaces knowledge as the base of the revised triangle, representing the first step in using knowledge, while understanding replaces comprehension to align with terminology familiar to educators. The next three dimensions are the verb forms of the same terms used in the original, while synthesize is replaced with create. Krathwohl's two-dimensional taxonomy lends itself to display as a table, where objectives and assessments can be evaluated on which dimensions they represent. For example, an objective that states the student will be able to classify insect species in phylum Arthropoda and organize examples into taxonomic framework would occupy cell B4, representing higher learning processes. Another objective might state the student will be able to recall the order of a mathematical operation, and would represent the lower learning process of cell A1. In order to illustrate Bloom's taxonomy in backward design, I will apply the tools to the development of learning objectives for an online tutorial that will teach the radiographic processes involved in knee imaging for the orthopedic or ortho department. Most X-ray exams are complex in nature and require the technologist to remember, understand, apply, and analyze information. I have chosen the Ortho Knee series because there is an added level of precision needed due to the high standards of the ordering physicians. Starting with the backward design model, the first question I ask is, what info is worth being familiar with? This represents the most basic level of information, and the answer is the names of our orthopedic providers. This is a nice-to-know tidbit, as each order form identifies the ordering department, so even if the tech can't recall the names of specific orthopods, they will be able to see that the ortho department is involved. Next, what should be mastered? This information constitutes the important concepts like machine parameters, appropriate angulation of the tube, effective communication, and the ability to correct positioning errors that are critical to successfully performing the exam. The third question is to ask, what are the big ideas and important understandings participants should retain? Skills such as alternative positioning methods and their advantages or disadvantages, the theory behind why we do these particular positions, and how to evaluate a patient's abilities to comply with the demands of the exam are examples of these. Since the nice-to-know item has little bearing on the performance aspects of the tasks, and physician rosters change depending on the site, I won't use the doctor names information in the objectives. On the other hand, those items under To Be Mastered and Big Ideas are vital not only to the specific series in question, but also for the general practice as a technologist. So these elements will go into the course objectives. Using Bloom's taxonomy, I have identified the knowledge aspects, the nouns in blue, and the cognitive process aspects, verbs in red, of the learning that I want to transmit, and can now take the answers to the key questions and formulate goals. Just for fun, let's use Krathwohl's matrix to evaluate my goals. Goal 1 calls on the student to recall or remember facts. In this case, exposure factors, as well as to modify or create new instances of the recall. So this goal covers 2 cells in the matrix, here and here. Goal 2 requires evaluation and correction of positioning errors, which requires procedural knowledge. So let's put that goal here on the matrix. Goal 3 tasks the student with altering or creating a new way of doing procedures. So that goes here. Goal 4 again calls for evaluation of information, in this case patient communication needs, and for choosing the appropriate methods. It appears that the majority of the goals require higher cognitive processes, which makes sense due to the multifaceted and complex nature of the job. There are, of course, areas that might require more activity in the remembering area, understanding and applying processes, such as being able to identify anatomy and recall organ functions, but those skills are not key to this subject. I can now expand upon the stated goals and begin to get ideas for assessments and content by responding to the prompts in the UBD design template available at the link in the lower right-hand corner. This will figure prominently in my next presentation, so tune in next time for a discussion on these points.